is air. And more specifically, air pressure. Does anybody know what the definition of air pressure is? Yeah.
It was made of oxygen.
Okay, good.
That's all.
Okay, right on. I like it. I recognize the definition of air pressure is a tough question to start you guys off with. Does anybody know, or can anybody think of any objects that might involve air pressure? For instance, yeah, go ahead.
CPR.
Okay, CPR for sure. I like that one. Never had that one. Yes, you are correct. Yeah.
Balloons.
Balloons, great. Come back to you? Yeah? Okay, yeah, buddy.
Airplane.
Airplane absolutely involves air pressure. Yeah, buddy.
Fighter jets.
Fighter jets, yes. Okay, good. Anybody else? That's fine. Anybody else? Yeah. Your sinuses. Yes, I will actually come back to that. Yes, oddly enough. Don't spoil the demo. Yes, it's football season. Footballs, basketballs, soccer balls, volleyballs, beach balls. Baseballs does not have air inside of it. Good guess though. Yes.
I don't know if this counts, but I do know there's like some kind of like I think of air whenever like the jet passes the sound barrier.
Okay, that doesn't have to do with air pressure, but yes, air is involved. No, I like where your head's at. You must really like jets. Somebody said a car tire. My friend right here. Am I correct? Somebody say a car tire, bike tire. I thought I heard that. Oh, it was you up there?
Yeah, he said it.
Oh, up there. Sorry, I just heard the sound. Didn't know where it came from. Yes, you are correct. Car tires, bike tires. Those also involve air pressure. The definition of air pressure is the amount of air in a given space. So what that means is areas that are, let's say, large, like this room, for example, has a lot of air inside of it, right? So it has high air pressure because there's a lot of air in this room. Areas that are very small, like the inside of this glass, have very low air pressure because there's not a lot of space. What did I just pour into this glass? Water, right? Not a trick question. I poured water into the glass. Why would I do that? Well, because I want to make the space smaller than it originally was so that no water comes out. What is holding up the plate and the glass right now? Not a trick question again. Yeah, buddy.
Water.
Okay.
Your finger.
My fingers, right? My hands. What if I let go? Now what's holding up the plate and the glass? Or more specifically, the plate? Yeah.
Nothing.
Okay, good guess. Somebody said it. I thought I heard somebody whisper it. The acoustics in this room are phenomenal. Yeah.
Air pressure.
Air pressure, correct. Does anybody know why air pressure is holding up the plate right now?
Wait.
Hmm.
No.
Can you put I'm so pleased that I didn't have it.
Well, I'm going to explain how it happened, I promise. Does anybody know why air pressure is holding up the plate right now? Yeah, buddy.
Because the water on the edge of the glass was sticking to the plate for a long time.
Okay, good guess. Anybody else? Air pressure works like this. Air likes to be equal. It likes to be equal pressure at all times. High air pressure, so this room, the air in this room, the area around the plate and the glass, likes to try to get to areas of very low air pressure, so the smaller space, right? So the air in this room is trying to get into this little space in the glass, but it can't because the plate and the water are stopping it. Does anybody know what it is called when you relieve pressure?
No.
Okay. Or break a pressure seal? You do it in airplanes when you do this.
No.
And pop your ears. Anybody know what it's called?
Air pressure.
Okay.
No.
I said the word earlier, I just realized.
Release.
Who was paying attention? Release, okay, good guess. Starts with an E. Equalize, correct. Equalization occurs when you break a pressure seal in some way. It can be popping your ears in a plane or underwater. If your sinuses are clogged up, it could be blowing your nose. For this, all you have to do is just tap on the plate and we're good to go. Who knows the 3 things that I need to make fire? Yeah.
A lighter.
Okay.
Sticks.
Okay.
And
And what?
rocks.
Okay.
Leaves.
Okay.
It's a good example.
Oh, okay. We got you. Yes.
Air.
Air. Yes, correct. Air. Oxygen. The bigger a fire is, the more oxygen it must use to consume. Anybody else? Yeah, buddy.
In the past, like the Stone Age first discovered fire, they had to use rocks or flint, and I think steel or rocks with wood and a campfire.
Okay. Good. I'll come back to that. Does anybody know what like flint and steel would be called?
Ignition.
Correct. It is an ignition source. An ignition source is anything that creates a spark or an open flame. It could be flint and steel, so friction. It could be an electrical spark. It could be a lighter. It could be a match. Something like that. What is the last thing I need? You guys were close with wood. Yes, correct. Fuel. Is that what you were going to say? All right, right on. Fuel source. A fuel source is anything I can feed into the fire. It is what keeps the fire going. Popular fuel sources are, logs, sticks, paper, leaves, gas, oil. Those are all popular fuel sources. My fuel source today that I took out and placed in that spoon right there is something called lycopodium powder. Lycopodium powder is remarkably flammable. It comes from mushrooms.
No.
Maybe not necessarily the mushrooms. No, it doesn't. All right, no. I'll fact check myself later on. Maybe not necessarily the mushrooms you eat. I don't know what kind of mushrooms. But what lycopodium powder is primarily used for is it is used for bright burning flashes or explosions, much like you will see here in a moment. Question for you guys. Given that information, what would happen if I lit a match and dip it into the powder?
Candle.
Hmm?
It would light a candle.
Light the candle, okay. Any other guesses? Yeah.
It would cause a chemical reaction that would, like a physical change that would turn into like something that is non-undoable.
Okay. Okay. Anybody else? No other guesses? So we have, it would, what did you say? It would light the candle?
Yeah.
Okay. And you said physical reaction, that would be undoable?
Or chemical, because you won't be able to change it.
Okay. So does anybody think it will combust? It will ignite? Show of hands, if anybody thinks it will ignite. Okay, you guys? Yep, okay, all right, right on. Who thinks nothing will happen? Okay, okay, right on. Is there any other guesses before I do this?
Me.
Okay, right on. Those guys who said nothing happened, or nothing would happen, were correct. Why were they correct? Who knows? What was I missing? Let's phrase it that way. Yeah.
Because you didn't light the candle.
I wasn't intending to light the candle, but good guess.
5.
What was I missing?
5.
Yeah. Nope, have my fuel.
Oxygen.
Correct, I was missing my oxygen, right? My fuel source is still in my spoon, right? The powder's still in the spoon. Obviously the match lit, so my ignition source was good to go. But in this form, while it's sitting in the spoon, the powder is too dense. My fuel source is too dense for oxygen to flow through. You need all three. But we can change that real quick. Give me a second. Right on. All right. What's gonna happen in a moment is I'm gonna turn out the lights so you guys can see, which I just realized is an oxymoron, but okay. I'm gonna turn out the lights so you guys can see. After I do so, I'm going to point the funnel end of my tube toward my ignition source, my open flame, my candle. I'm then going to say 3, 2, 1. After 1, I'm going to exhale into the opposite end of the tube, dispersing the oxygen from my lungs, and the powder from earlier over my ignition source. And it should, if I've done it right, make a fireball for you guys, all right? Cool. A little bit of a noise with this, nothing too loud, but just a heads up. All right. 3, 2, 1. All right, right on. This is safe to breathe in unless you actively have bronchitis right now. Cool, so that worked because I have all three components working in cooperation with each other. Earlier with my match and spoon, my fuel source was snuffing out all of my oxygen because it was too dense, but there was a much finer grain, so my oxygen was able to flow through and combine with my fuel source and my ignition source. Yeah.
Where did you buy that?
What did I buy? This?
Yeah, the thing you blew through.
Oh, this
Yeah.
tube, and I have no idea. I feel like my boss just took some sort of rubber tubing, cut it open, and stuck a funnel.
No,
Imagine
I
that's how
don't
it's
like
done.
that.
Does anybody know what this is?
A balloon maker.
Okay, good guess.
A Tesla coil?
Correct, it is a Tesla coil. A Tesla coil was invented by a scientist named Nikola Tesla. He studied electrical conductivity, which is essentially how electricity works. Yeah, buddy.
I'm really named after many famous people.
Right? What's your name?
Nicholas.
Ah, there you go. Right on.
Because I'm famous from it. My name is famous from a famous astronomer.
Okay.
Now, the first Tesla.
Okay. Right on. Just so
I
popular. I like it.
it.
So, a Tesla coil was invented by a scientist named Nikola Tesla. He studied electrical conductivity, which is essentially how electricity works. What a Tesla coil was used for is long range, well, we used it for long range television and radio broadcasts. The design was to amplify some sort of electric charge. Before I demonstrate this, does anybody in the audience have a pacemaker? Don't raise your hand for that unless you have a pacemaker, bud. If you don't know what it is, you don't have one. Okay, no pacemakers? Right on. You had a question though?
No.
No? Alright, right on.
I just didn't know what it was.
Fair enough. Alright, so how the Tesla coil works is the wall is giving me about 110 volts of electricity. That's nothing special. It's an ordinary outlet that you guys have in your houses, classrooms, offices, whatever. But if I turn the Tesla coil on, and if I crank it all the way up, I could get us to about 750,000 volts. I'm not going to be doing that just because I'm standing a little close. I'll get us about halfway there at 300,000 to 400,000 volts. I'm going to turn off the lights again so you guys can witness the electrical spillover that will come out at the top of the Tesla coil. One thing to keep in mind is there's a little bit of a crackling noise. So if you have a little one that is super duper sensitive to loud noises, I promise everybody will be fine. But just cover their ears, all right? All right, cool. Lights off. 3, 2. If you would like to take photos, videos, feel free to do so. All right, right on. 3, 2, 1. Everybody good? Right on.
Cool.
Question for you guys. Last question.
It's open.
Why does that come out purple at the top? Oh, you have a question. Yes, go ahead.
Is that like when you get like infected or something?
Is that like when you what?
Like when you get infected or something?
Is
Like
it
electric.
Oh, like an electric shock? Okay, yes, that can totally give you an electric shock. Yes.
I know why there's purple or blue electric coming out of it.
Why?
It's because there's so much energy like coming from the bottom of it that it's lifting up into the tube where a lot of force is trying to like almost like smash into each other that turns like that makes electrical charges.
Okay, that is definitely how the electrical charge works. It does come from the bottom and it does get forced through the top and it gets stronger. That is not what makes the color purple though.
I did not know that.
No, you
I
were right.
just yes.
No, you were good. Anybody else know why it comes out purple at the top?
No.
Nope.
Dad.
Yeah.
No.
Why was the
You say, why is this sparking?
why does it come out?
Yeah.
Because it needs somewhere to go. Is the shortest possible answer. All of this electrical charge that comes to the wall comes up from the bottom of the Tesla coil through the copper and out the top. It just needs somewhere to go. Same thing if you were to fill up a glass too much with water. The water has to spill onto the table, right? If you fill it up too much, same kind of concept, but with electricity. Nobody knows why it comes out purple? All right, let me ask this. What are the 4 main gases in the atmosphere? our atmosphere. Yes.
Hydrogen, carbon dioxide, oxygen, I think I said, but also
It is not helium. Good guess. Yeah, but
Nitrogen.
nitrogen, that is the last one. So the electrical magnetic discharge mixes with the oxygen, nitrogen, hydrogen, and carbon dioxide, creating that purple color. Does that phenomenon happen in real life? Yes, absolutely. If you were to witness a thunderstorm up here in Connecticut for the majority of the year, you will probably witness the lightning as sort of a whitish blue color. However, if you go down south somewhere, or you are in a part of the world with more humidity, more hydrogen, you will probably witness the lightning as more of a purplish blue color. And heat lightning is kind of a yellow or yellow-red because there is less nitrogen in the air, right? It is more of a dry environment. Any last minute questions for me?